All right, so for this one, it says consider this curve. There it is, defines this equation. And then the first question asks us to find dy dx, or to show that dy dx equals this. So to get dy dx, we have to derive with respect to x. And you'll notice that we don't only have x's here, we also have y's. That means we're going to have to use implicit differentiation when we derive the y terms. Okay, so I'm going to set it up. I'm going to be explicit. I'm making sure my grader knows what the heck I'm doing. I'm taking the derivative with respect to x of this equation. The first term right here, the derivative, we drop the 2 and we take 1 away from the 2, so you get 2y. And then you multiply it by dy dx. That's the chain rule, okay? Because we're taking the derivative with respect to x, but this is a y, we have to assume that y is a function of x. So we took the derivative of the exponent, the 2, and we got 2y. And then we have to take the derivative of the inside function, which is y, which is dy dx. Don't forget dy dx equals y prime. Okay, now we have the next term. What's the derivative of 2y? That's just 2. But because there's a y, now we have to take the derivative of y, which would be dy dx, or y prime. The rest of the terms are really simple. They're normal, okay? We have an x term here, we have an x term here, and then we have a constant. The derivative of x to the fourth is going to be 4x to the third. You take 1 away from the exponent, you drop the 4, multiply it as the coefficient. And the next one is just going to be 4. And if for some reason, guys, I don't know if this ever happened to you, but I always forget the other side if there's just a constant. But you have to take the derivative of that as well. It's very important. That equals 0. Now, if we're trying to show that dy dx equals this, we have to get the dy dx alone. So you'll notice we have 1, 2, 3, 4 terms right here. 2 of these terms have a dy dx, and the other 2 do not. So I'm going to move the other ones that do not have a dy dx to the other side. Simple algebra. Now this side, I'm going to factor out the dy dx to get this. 2y plus 2 times dy dx. Now to get the dy dx alone, you guessed it, we just divide both sides by 2y plus 2, and we get this. Now my dy dx is alone, but it doesn't quite look exactly like this, and that's what you have to do. You have to make it look like that. And so when I'm looking at this, I realized, hey, I could take a 2 out of the top and a 2 out of the bottom. So I rewrite it, and I actually took out a negative 2 here, but I saw negative 2 divided by 2, and so now I have a negative 1 up top and then no more 2 on the bottom. And now it almost exactly looks like this up here, but I had to take out the 2. I had to factor out another 2. So I do that, and once you guys get it to look exactly like what they're asking for, you're done. It's checked. It's done. That's worth 2 points. All right, for our next problem, it's saying, write an equation for the line tangent to the curve at this point. I was just talking to one of you guys, and I was giving you guys the tip. Hey, whenever you see a number, know what that number is. You might want to label it so that you don't forget later, but identify what that number is. So I'm going to say, well, this is just an x and a y. Who cares? All right, but now, a tangent line. Remember, that's just point-slope form. This is the algebra way to write it. I didn't write f of a right here, and I didn't write a right here because the problem doesn't define an f for us. So actually, I'm going to make this xy, x1, y1, because that's probably going to be what I'm throwing in right there. Now what we need to know is this slope. Now the calculus concept is that you know dy dx is the slope. So we got to find dy dx. And we're going to find the dy dx at 1, negative 2. And so to do that, we plug in the 1 and the negative 2 to the dy dx that they gave us earlier. So I'm going to do that, plug it in, and then do some simplifying. I think I did make a mistake here. Does anybody catch my mistake? No? Nobody caught it? 2. Yeah, okay. So what is 1 plus 1? That's supposed to be a 2 right there. So I made a mistake. So here, I fixed that here in a second. Let's see, let's get rid of that 2. Hurry up. Okay, so this is supposed to be a 2. So negative 2 times 2 is going to be negative 4, and then we divide it by negative 1, which gives us a positive 4. That's our slope. And then we just plug in the 1 and the negative 2 to the x and the y spot. And then normally what I like to do is get the y alone, just because usually if you're doing multiple choice, that's what they do. They get the y alone. You get 2 points for this one. You get a point for the final answer, and you also get a point for finding the slope. All right, for letter C, it says find the coordinates of 2 points on the curve where the line tangent to the curve is horizontal. Guys, if the line is going to be horizontal, its slope has to be 0. And so you should state that. You should take the dy dx and you should say, hey, this dy dx has to be 0. You will get a point just for writing this because you're showing, hey, I know that the slope has to be 0 right here. And that's a big deal. Okay, so I take out the dy dx, I put in what dy dx equals, the denominator goes away because algebra, and then the negative 2 goes away because algebra, and then you can solve it. Now there's 2 ways to solve it right here. Admittedly, I thought of the more complicated way, which I'm going to explain to you guys really fast, and then I'll show you guys the simplified way. Okay, the complicated way is recognizing that this is a sum of 2 perfect cubes. And when you recognize that, you know that it factors to x plus 1 times x squared minus x plus 1. Now, not everybody remembers this, so the other way is actually easier. But I'm going to explain this really fast, just in case you guys need it for the future. The sum of 2 cubes. Okay, so this is, here's the formula. Here's a quick review. We have a sum of 2 cubes and we have a difference of 2 cubes. This one's the sum and this one's the difference. Notice that the other side of the formula is almost exactly the same. The only difference is the signs. And to remember the signs, I remember keep, change, plus. Keep the sign, change the sign, plus. And so the first one's going to look like this. We keep this sign, we change the sign, and then plus. The last one's always plus. So what's going to be this sign right here for this formula? Remember, it's keep, change, plus. So what's this sign going to be? Minus, and this one's going to be a, and then, all right, so now in our problem, we are going to use this one. This is the sum of cubes that we're going to use. We don't use the difference. We have x cubed, which is a perfect cube, and we have 1, which is a perfect cube. And so I was able to factor it out like so. Then you take each of those factors, set them equal to 0, and solve. This one, you get a negative 1. This one actually doesn't work. And so just to double check it, I plugged it into a quadratic formula. I don't know if you guys remember the quadratic formula. Do you guys remember the negative boy who couldn't decide whether or not he wanted to go to this radical party? So the square boy missed out on 4 awesome chicks. And the chicks are the birds. You know, I don't know what you're thinking about, like the birds. You know, like little, I guess they bought birds or something. And instead stayed up all night until 2 a.m. Playing video games. And when you do this, you get a negative inside the square root, which means this is an imaginary number, which means nobody cares. Okay, so the other way to do it is just to solve the equation like so. You just move the 1 to the other side, then you cube root both sides, and you get x equals negative 1. So yeah, you don't have to do all this extra stuff if you thought of it that way. All right, so now we're trying to find the 2 points. We identified that the x would be negative 1. What do we have to do to find the y's? We got to plug it back into the equation. So you plug the x into back into the equation. I put the equation right here so we can see it. A little bit of algebra would give us a quadratic, and then we have to factor it, and then we solve it. We get y equals 2 and negative 4. So that means we got our 2 points. We got negative 1, 2, and negative 1, negative 4. Those are our 2 points where the tangent line is horizontal. Now, I've noticed this a few times on some of your papers, and I've noticed this on the scoring guides from the College Board. A lot of times they explain the answer, even when it doesn't ask to be explained. This is actually a good practice because sometimes you go to explain it, and you look back at the question, and you realize, whoa, I must have done something wrong because blah, 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 whatever the scenario might be. So it's not a bad idea to explain your answer to yourself. This is where we find the horizontal tangent lines, because that's what it's asking. Find the coordinates of the 2 points on the curve where the line tangent to the curve is horizontal. Okay, so that's the end of that one. All right, now we're finally at D, and this one, honestly, I think College Board messed up all the way till the end on this one, and then put a little Band-Aid on it. And let me explain to you guys. Is it possible for the curve to have a vertical tangent line at points where it intersects the y-axis? What the heck? Where would you even start here? Okay, so when you are doing this, remember, we're trying to find calculus concepts. And so the calculus concept here has to do with the vertical tangent lines. Okay, so let's start at that point. The vertical tangent lines. Now, what you should know is that the denominator has to equal 0 in order to get an undefined slope, so you can get vertical tangent lines. Vertical lines have undefined slopes. So you just take the denominator, set it equal to 0, you get -1. So right now you know that the points that will give you a vertical tangent line will have a y that equals -1. This is where this guy comes in. Now, if you know that the y equals -1, how do you find the x value? You plug it back into the original equation. And so we plug the -1 back into the original equation right here. And this is what happens. Okay, so like I honestly probably wouldn't have thought about using this yet. I would just plug in the -1 and I would start solving it, and then I ran into a problem. Whenever you guys run into a problem for an FRQ, go back and read the FRQ, because it probably gives you information that helps you solve the problem. Because how can we solve for this? This is a gnarly Algebra 2 trig problem. What you have to do here is you have to find possible rational zeros. You have to do synthetic division. That takes way too long. And so you have to assume College Board is not asking me to do all that stuff. So what else did they tell me? Well, they told you where it intersects the y-axis. What does x equal when you intersect the y-axis? It equals 0. So really what we're testing is 0, -1. Does 0, -1 exist? Well, we plugged in -1 right here. Now we have to plug the 0 to see if it works. And when you plug in the 0, look what happens. We get -6 equals 0, which is not true. Therefore, the y-intercept on this equation do not have vertical tangent lines. And that's the end. That's the end of that problem.